Hi children, how are you? Hope you are doing well. After a small gap, we are going to see chemistry again. Unit 1, Solid State. Hope you have studied the old portion. Is it? Okay. Now we are going to see about point defects. The fourth subtopic under this unit, point defects. Defect. What is defect? It is otherwise known as imperfection. Any departure from the perfectly ordered arrangement in a crystal is known as defect. In your syllabus, point defect is given. What is point defect? Point defect is caused by the particles in the group of atoms in a crystal. Caused by the particles. So, point defect caused by the particles. Under point defect, we are going to see three types. Number 1, stoichiometric defect. Number 2, non-stoichiometric defect. Number 3, impurity defect. About stoichiometric defect, first let us see. Stoichiometric defect. During this defect, stoichiometry is not disturbed. What is stoichiometry? Stoichiometry is nothing but study of the quantitative relationships or ratios between two or more substances. During this stoichiometric defect, density of the substance also changes. Under stoichiometric defect, we have to see two types of defects. One is Schottky defect and the next one is Frenkel defect. First, when we see about Schottky defect, this defect arises due to unoccupied lattice points. You know, lattice points occupied by cations and anions in an ionic crystal. This lattice points unoccupied means we will say that defect is Schottky defect. So, during this Schottky defect, there is a decrease in the density of the crystal. Usually in sodium chloride, potassium bromide and cesium chloride and all undergoing this type of Schottky defect. And some more points you may collect through your books. Okay. I encourage you to collect some more points. Okay. And Frenkel defect. When we see about Frenkel defect, this defect arises due to ion leaves its site and occupies interstitial site. Usually, cations are involving in the movements. Cations move from its original lattice site and occupies interstitial site. So, during this Frenkel defect, density of the solid does not change. Usually in silver halides and zinc sulfide, this Frankel defect occurs. Non-stoichiometric defects. When we see about the second type of defect, stoichiometry is disturbed and electrical neutrality maintained. Under this non-stoichiometric defect, we have two types. The first one is metal excess defect and the next one is metal deficiency defect. This metal excess defect arises because of two reasons. First, it arises due to anion vacancies. This type of defect arises when an anion is missing from its lattice site and the hole thus created is occupied by an electron. The electrons trapped in anion vacancies are called F centers. It's very important one. F center. What is F center? F for Farb. It's a German word meaning color. Because of F centers, color created in the crystals. For example, violet color to KCl and pink color to LiCl crystals are created due to F centers. What is F center? Can you repeat with me? Electrons trapped in anion vacancies. Electrons trapped in anion vacancies are called F centers. Under metal excess defect, the second reason is due to interstitial cations. Due to interstitial cations. This type of defect arises when an extra cation is present in an interstitial site. That means the space between lattice site occupied by extra cation means we will say that is metal excess defect. The electrical neutrality is maintained by the presence of an electron in some other interstitial site. You know, in non-stoichiometric defect, electrical neutrality maintained. Here in metal X defect due to interstitial cations is electrically neutralized by the presence of an electron in some other interstitial site. For example, zinc oxide is white in color at room temperature, but at high temperature it turns yellow. The excess Zn2 plus ions are entrapped in interstitial sites and equal number of electrons are trapped in the neighborhood to maintain electrical neutrality. These electrons absorb light from the visible region and radiate yellow color. So, example for the second type of metal excess defect is zinc oxide. It's yellow in color. So, question may come this like. Zinc oxide is yellow in color at heated environment, or during heating zinc oxide is yellow in color, but zinc oxide is white in color at room temperature. Give reason. So be prepared. Under non-stoichiometric defect, the second type is metal deficiency defect. Metal deficiency defect arises due to cation vacancies. When a metal ion is missing from its normal lattice site and the charge is balanced by a nearby metal ion having higher positive charge, means that type of defect is known as metal deficiency defect. Because in non-stoichiometric defect, electrical neutrality maintained. So, metal ion missing from its normal lattice site, due to metal ion missing, some charge is missing. Is it? This is balanced by a nearby metal ion having higher positive charge. So, this type of defect occurs in those compounds where metal can exhibit variable valency. Variable valency carrying metals. Can you say some examples? Yes, iron, then copper, these and all examples for variable valency metals. Okay, so when we see about iron oxide, iron sulfide, the formula is FeO, Fes and nickel oxide. These and all involving metal deficiency defects. The third type of defect is impurity defect. Impurity defect. It is caused by the presence of foreign substances. The process is known as doping, and the crystal which involved doping are known as doped crystal, and another name of this doped crystal is solid solution. Under impurity defect, we have two types of crystals. The first one is interstitial solid solutions, and the second one is substitutional solid solutions. Interstitial means in a crystal, suppose foreign substances occupying interstitial space, means that type of crystal is interstitial crystal or interstitial solid solutions. Suppose in a crystal, the foreign substance occupying or replacing one of the lattice site and occupies that space. Lattice site means that is known as substitutional solid solutions. Under substitutional solid solutions, we have two types. One is covalent, another one is ionic. Due to covalent substitutional solid solutions, semiconductors are created. Semiconductors formed by the use of this covalent substitutional solid solutions. Under covalent substitutional solid solutions, semiconductors, we have two types. One is N-type semiconductor and the next one is P-type semiconductor. N for negative, keep that like in mind. P for positive. When we see about N-type semiconductor, electrical conductivity is due to electrons, and P-type semiconductor, electrical conductivity is due to holes. Holes means whenever electrons missing, that site is known as hole. Or electron deficient bonds. I mean P-type semiconductors conducting electricity due to the presence of holes are electron deficient bonds. Okay, when we see about examples for these two semiconductors, N-type semiconductor. N-type semiconductor is formed due to group 14 elements like germanium and silicon is doped with group 15 elements like phosphorus and arsenic. When we see about group 14 elements, that the valency is 4, and group 15 elements valency is 5. So due to excess of one electron in group 15, there is a conduction of electricity. That's why this is known as N-type semiconductor. And when we see about example for P-type semiconductor, it is formed due to group 14 elements like germanium and silicon is doped with group 13 elements like gallium and aluminium. So when we see about group 13, the valency is usually 3. So group 14 and group 13, when doped with each other, when during doping, there is a missing of one electron. So hole arises. So due to the presence of hole, there is a conduction of electricity. So we have studied about impurity defect. Hope you can understand the whole topic. Point defect. Let us recollect all once, okay? When we see about point defect, 3 types: stoichiometric, non-stoichiometric, and impurity defect. Under stoichiometric, 2 types: Schottky, Frenkel. Under non-stoichiometric, 2 types: metal excess, metal deficiency. Under impurity defect, 2 types: interstitial, substitutional. When we see about substitutional, covalent and ionic is there. Due to covalent substitutional solid solution conductors are formed. There is 2 types of semiconductors. One is N type and the another one is P type. Thank you.